Welcome. I'm quickly going to explain how to find the derivative of the function y equals 10 times x to the ln of x power. Our goal is to find, and actually let me name this f of x. And we want to find f prime of 2. So let's start by first thinking of how to set this up. We can have this written as y equals 10x ln of x. And I know I just changed it to f of x, but that's so we can use this function notation for evaluation. So now what we need to do is actually find this derivative. And actually, give me a quick second. I am at home in the lockdown, and I need my child to turn down the iPad. Anita, can you lower the volume on your iPad a little bit, please? So we can learn the video. Please. This is going to help you lower the volume. Please. Okay, so now we won't be hearing Elsa 2 in the background, so hopefully I won't be in trouble for broadcasting Elsa 2, right? So now let's find this derivative. Let's rewrite this first using ln's. So I'm going to, let's copy and paste this, copy, paste. And I'm doing that so I can show every step in detail. So we have ln of y and then ln here. So now we can use some clever algebra. We have ln of y equals ln of 10 plus ln of x to the ln x. And what did I do here? Well, if we have ln of a times b, this can be written as ln of a plus ln of b. Okay, so that's the clever algebra there. Now we're going to use implicit differentiation to find this derivative. So I'm going to copy and paste this again, and that's so I can show every step. So I have, and let me leave some space here and here. We want to find the derivative with respect to x of both sides. So on the left-hand side, we end up with 1 over y times y prime. Ln of 10 is just a constant, so this is going to become 0, plus, and then actually, before I find this derivative here, let me rewrite this. So I think I shouldn't have skipped a step. So I'm going to move this down and rewrite this algebraically as ln of y equals ln of 10 plus ln of x times ln of x. So what just happened here? Well, there's another rule with natural logs, or with logs in general, that says if you have ln of a to the b power, this becomes b ln of a. So I just moved this exponent here to the front. And if you notice, this is just ln of x squared. So let me rewrite this here as ln of x quantity squared. So now when we find this derivative here, we need to use the chain rule. So we have a 2 in front, and we multiply by the inner function of ln of x, and then we multiply by the derivative of ln of x. So this becomes 1 over y times y prime equals 2 ln of x times 1 over x. And now I can keep rewriting this algebraically as y prime equals 2y ln of x over x. If you notice, all I did was multiply y to both sides. Now that that is done, we don't want our derivative in terms of y. What is y? Well, we were told y equals 10 ln of x. And actually, since I'm losing material, let's move this down here. There we go. So let's replace this y with this entire function value. So this becomes 2 times 10x ln, that should be an exponent, ln of x times ln of x over x, which becomes 20 times x ln of x to the times another ln of x divided by x. And we can rewrite it just one more time as 20x, and the exponent is ln of x minus 1 times ln of x. And now this is f prime of x, is all of this. Now if you want to find this evaluated at 2, just go ahead and plug in a 2. This tells us that f prime of 2 equals 20 times 2 to the ln of 2 minus 1 power times ln of 2. And you should get something like 11 and change here when you plug this into your calculator. So let's do that together. And I can put a calculator here on my screen to the side. So we have 20 times 2. And in my exponent, I'm going to put ln of 2 minus 1. And then get out of that and multiply this whole quantity by the natural log of 2. And you get about 11.206 and a bunch of other decimals after the fact. So hopefully this helps. If you were in the chat this morning, I apologize for doing it incorrectly. I incorrectly started using the power rule here, which is just a huge mistake. I think this shell trade in place with your children has been a little tricky, and I was distracted with the 17-month-old. So I hope this video helps.